Welcome to the CAMWorks portion of GoEngineer's All Application Webcast series. The topic for this webinar is Optimize CNC, using CAMWorks to increase your productivity. My name is Tyler Reed, and I'm the CAMWorks Product Specialist here at GoEngineer. I'll be talking about CAMWorks, but for those of you watching live, I encourage you to stay tuned after my webinar and watch some of the other ones we have going on today. We have Altium Designer, SolidWorks Enterprise PDM, SolidWorks Simulation, Stratasys 3D printers, and 3D via Composer webinars all coming up today. And for those of you watching this after it's been recorded, all of those will also be available at goengineer.com and youtube.com/goengineer. Today's topic is going to be the basics of CAMWorks. We're going to be talking about how CAMWorks is integrated into SolidWorks, some of the most basic features of CAMWorks, what sets CAMWorks apart from your conventional CAM software. We're going to be talking about the technology database and how to leverage it to make your programming more efficient and quicker and easier. And then towards the end of the webinar, we're going to be taking a part that we programmed in part mode, pulling it into an assembly, mounting it on a tombstone, and programming in assembly mode. Something that's going to be fun to watch, and hopefully you'll learn something. We're going to jump over to SolidWorks, and we're going to start from the beginning here. So my hope is that those of you watching will have a varied experience with CAMWorks. This webinar will be good for those users who are just beginning, and also users who have been using CAMWorks for a while and want to pick up some tips and tricks. Notice here we're in SolidWorks, and everything we do in CAMWorks is going to be in SolidWorks. We're never going to move outside of SolidWorks, which is great for a few reasons. One, the user interface is going to be very intuitive and hopefully familiar to you. It also means that as our SolidWorks model changes, the CAMWorks model keeps its parametric relation to the SolidWorks model. So we'll see here, as we start to program the part, we don't have to be afraid about the SolidWorks model changing down the road because our toolpaths and our CAM data will update. We'll show an example of that in a bit. For now, let's take a quick look at the origin of this part. So it's a basic hook mold, and this is what we're going to be programming. To give you an idea of what it started out as, it was this. So through the power of SolidWorks, I was able to create a negative mold, basically for the purposes of this webinar. So now let's head on over to our CAMWorks tabs and let's get cracking. As I go through this, we're going to start by manually inserting a single feature, and we're going to go through most of the details that are involved in creating that feature manually. I'm going to stop and discuss most of the features as we go along. So stick around. It's going to be a little bit slow at the beginning, just so I can give you the info that you need. And then once we do one feature, we'll go and edit it, and then we'll run automatic feature recognition, and we'll get the rest of this part programmed fairly quickly. So, as I mentioned before, we're inside SolidWorks, and we're utilizing the SolidWorks user interface, which is great because it's intuitive, and it normally goes in order, meaning top to bottom, left to right. So real quickly, we'll just start here top to bottom in the CAMWorks feature tree. The first entry here is configurations. And I'm not going to show configurations today, but I at least want you to know that if you use SolidWorks configurations, you also have the option to use CAMWorks configurations, which is essentially multiple programs for the same part that might differ slightly. Or alternatively, if you have a part that has turning operations and mill operations, then you can do a turning configuration and a milling configuration. Next here is a stock manager. Stock is super important when it comes to CNC, right? Because that's the beginning point of everything that's going to be automated. So by default, CAMWorks creates a stock that's a minimum bounding box size over the part. And we can create offsets from there as needed. We also have the option of using a sketch, and that's what I'm going to use today. In my SolidWorks model, I have a sketch called stock which is tied to the bottom edges of my part. It's tied to the edges, meaning if the model ever changes shape, my stock sketch will change shape, and then my CAM data and my stock material will again change shape. So I'm going to choose that stock sketch, and then for the depth, rather than just choosing a blind set depth, I'm going to click this top face so that it's tied to the face. And then I'll add an offset from there to give us a little bit extra material to face off. In the bottom left hand corner here, my material is aluminum 6061, which is good enough for me today. The material list that you saw is my favorites list from the material library. So my favorites list had about 30 there, but the material library comes with over 1,000 materials. The next option here is the mill machine, which I have selected. Here's a good time to point out that CAMWorks offers solutions to almost all your machining needs. We can do milling, 2.5 axis to 5 axis simultaneous milling. We can do turning, 2 and 4 axis dual turret turning. We can do mill turn, up to 7 axis mill turn. And we can also do wire EDM, 2 axis and 4 axis wire EDM. Today we'll be discussing 3 axis milling. Next option here in the machine parameters is my tool crib. Not much to say about this for now, but it's important to know that CAMWorks takes into account what tools you have in your shop and attempts to use those when it makes suggestions on how you should program a part. Next tab is the post processor. I just have the default tutorial post processor selected here, but I have a couple dozen here in my library. And then we here at GoEngineer, on top of that, have over 1,500 mill posts available to our customers and prospective customers. These next tabs here, the setup, rotary, and tilt axis, we'll discuss these briefly when we go into assembly mode, but for 3-axis part mode, they aren't too applicable. If we were to do a 4-axis or 5-axis part, then this is where we would tell CAMWorks which axes were our rotary axes. So that about does it for the initial setup. We've got a stock and we've got our machine set up. And that's something that once you do once and you set your defaults, you shouldn't have to do again as far as the machine setup goes. So, in the CAMWorks workflow, the first thing that we need is a setup. And I'll create that. And then the second step that we need is a feature. CAMWorks is feature-based machining, similar to how SolidWorks is feature-based modeling. As opposed to your conventional CAM software, where you're left choosing a tool first and then fitting the tool where you can, CAMWorks identifies features, things like holes, slots, pockets, and those features, based on their size, the stock material, and their shape, will have certain operation parameters stored in a database. So for example, CAMWorks will know that when you choose a 1/2-inch hole in a drilling strategy, that you'll want to use a center drill, a drill, and say, if we're going to use a reaming strategy, a reamer. We aren't left to adding all of those manually. We can also create custom strategies, which we'll do here. Custom strategies is where your machining, your programming time is really going to decrease as you teach CAMWorks how you want to machine parts. So the first thing we need is a setup. And a setup is essentially just a direction that we're going to be machining from. So manually we're going to do this one setup, machining from the top direction. But notice this part will also need a setup coming normal to this face and also normal to this face. Later when we run the automatic feature recognition, we'll have CAMWorks create those setups for us. So there's our setup. Now let's add a feature. I'm going to use this pocket, which is an O-ring groove, as an example feature. This is going to be a 2.5 axis feature, meaning flat bottom. Things like holes, slots, and pockets, facing, part perimeters, all of that type of thing is considered 2.5 axis. This middle portion here would be 3 axis because it requires all 3 axes to move simultaneously during the feeds. So I'm going to right click on my mill part setup and I'm going to say insert 2.5 axis feature, and it's going to bring up the feature wizard. The feature wizard's job is to help me create these features. I already had that face pre-selected, so it filled it in here. And we're at pocket type. If I didn't have that face pre-selected, all it would require me to do is select that face. I also have the option of using these edges, or I could use the sketch that created this boss extrude. I'll hit next, and now it's asking me to determine the depth of my feature. So essentially what we're doing here is we're creating an enclosed volume that we can see here with the green outlines. My pocket isn't that deep, it only goes up to this face. So I'll just click that face and it will snap to it. It's important to realize what we just did there. We define the depth of the pocket by where that face is, as opposed to just setting a blind depth of, say, 50 thousandths. This way, if the model ever changes and if the pocket depth ever changes, the CAMWorks feature will update. The next we need is a strategy. That's this list here. So you can see right now I've got rough finish selected. Rough finish would give me a rough mill and a finish or a contour mill operation. Coarse would just give me a rough. Fine would give me just a finish. And you also have all of these other options here, like corner radius. What it would do is we'd come in and rough out this pocket, and then we'd come in and finish it, and then we'd come in with a third operation, the corner round tool, and hit this top radius here, or this top edge. This 130 degree chamfer is a custom strategy I've made to use 130 degree chamfer tool just to chamfer the top edge. And this O-ring groove strategy is it's a leftover from when I did this webinar earlier, and it's actually the strategy that we're going to save in just a minute here. We'll see what it is. It's essentially a finish mill with altered feeds and speeds, depth of cut, and tool. So for now, I would choose just fine, because that would be something that's available during the default. And I'm going to hit next. There's one last thing I need to do with this groove, and that's identify this island here. So I'm going to hit auto detect. And essentially what an island is, it's an area within the enclosed space of the pocket that we don't want to machine. So now you can see with the green outline we actually have our pocket to shape. So I'll hit finish and then close. So now we have a feature. What do we do with the feature? Well, what we do with the feature is generate an operation plan for it. An operation plan is essentially a plan of attack or a strategy for how CAMWorks is going to handle that feature. So again, based on the type of feature, so we have a rectangular pocket, the stock material, the length and width of the pocket, and the depth of the pocket, is all going to determine what type of operation and what feeds and speeds and depth of cut and tool CAMWorks is going to choose to machine this part with. And all of those values come from the database. So when I right click here and say generate operation plan, CAMWorks runs that feature through the database and it finds a matching entry based on all of those parameters I just listed. And when it finds an entry, it kicks you over to the operation tab and adds the operation that's associated with that entry. So you can see here what it found was a contour mill operation with a 1/4 inch flat end mill. So now that we have a setup, a feature, and an operation, the very last thing we need to do is generate the toolpath. And when I say generate the toolpath, I mean take all the parameters that are associated with this contour mill and apply them to this part or the specific geometry here. So I'll right click here and I'll say generate toolpath. And it won't generate anything. So we'll talk about what happens when you do that, how to diagnose it, and how to fix it. How do I know that nothing generated? Well, this stayed pink. And in CAMWorks, anything that's pink means nothing's associated with it. And when things stay pink, within CAMWorks, there's no message window that pops out at you and says, hey, something's wrong here. We're kind of left to our own experience, and also there's a message window here that we can manually pull up. So in my experience, when toolpaths don't generate, it's normally because the tool doesn't fit in the pocket or in the feature, or it doesn't fit between the feature and the stock. In this case, what we're going to be running into here is that this 1/4 inch flat end mill can't fit into this pocket. And if we pull up this message window here, we get a bit of a cryptic message basically saying that. So what happens when we run into that situation? Well, we can alter the operation parameters by double clicking into the operation, and we can select a slightly smaller tool. So that was a 1/4 inch tool. Let's choose a 3/16 inch. And I'll hit preview, and I instantly get an update there. Great. So this is part of the reason why I have that O-ring groove specific strategy, right? It's because out of the box, CAMWorks is going to give you a starting point out of the database. And normally it's very good. But it's not always how you're going to machine parts. And everybody's going to be machining differently, right? So by creating these custom strategies, essentially pulling out data from the database, customizing it to your needs, and saving it back to the database, you're teaching CAMWorks how you want to treat certain features. And then the next time I'm confronted with an O-ring groove like this, I would select my O-ring groove strategy, and I wouldn't have to make these types of edits. So what else can we edit about the toolpath? I just chose a different tool for my tool crib. What about these other parameters? So under the contour mill, we've got side allowance. It's basically set at 0. And you can see if I add some side allowance, these toolpaths should shift inward. Probably very hard to see. If we give it a little bit more. Not too big so it can't fit in there. Alright, there we go. So I gave it so much side allowance that now I can only create one pass. And I should mention that when we're looking at these tool paths, what we see here, the blue is the feed rate, and it's following the path of the mid bottom center point of the tool. This red square marks the start of the tool path, and the red dotted lines mark rapid movements. Okay? So set this back to 0 because this is a finished pass and we don't want any side allowance. Here's where we can adjust the depth parameters. So right now it's at 1/2 inch depth, and so it can do this pocket in one pass. If I were to reduce this depth and hit preview, it would force it to create several passages. So notice here how I'm coming in to the operation parameters, I'm making an adjustment, and I'm hitting preview here down at the bottom. By hitting preview, I get that very quick, instantaneous visual feedback of what my change did. That's going to be something you do a lot here in CAMWorks, especially as you're learning to program these parts. I can probably take off more than 10 thousandths here, so I'm going to bump this back up. Hit preview again. So I'm still doing it in one pass. Some of these other tabs that we have here are the NC tabs. So these are my rapid planes and my clearance planes. I can also control how the tool is entering and exiting. I have it set basically to plunge, but I can also do an entry drill or spiral in. In other operations, such as rough milling, we would have more options like ramping. We can also control the lead-ins and the lead-outs. Right now I have mine set to none. We can do Z-limits. And then also we can optimize the tool paths. Not much to optimize here, but if you imagine the scenario where, say we're milling out a plate full of pockets, well, initially CAMWorks might mill those pockets out in arbitrary order. Well, we can optimize by saying, take the shortest path or move inside to outside, outside to inside, what have you. Alright, I'm going to hit OK here. And I have some toolpath on this part. How accurate is it? How can I know? Well, we can simulate the toolpath. I can right-click on a specific operation and say simulate the toolpath. And I'll allow it to run through here. And it shows the tool moving through the part. Neat, but still I don't know how accurate it is. CAMWorks also allows you to run a comparison, which is basically a color-coded difference shower. I don't think that's the scientific term, but that's what it does. So what we're seeing here is anything that's green, according to the legend, is within plus or minus 4 thousandths of the part as modeled in SolidWorks. Anything that's blue is undercut. So anywhere where we're left with material would be undercut, obviously because we haven't cut that out yet. So this is a good way to check how accurate you are. And that's essentially all there is to it. That's how we manually create a feature, run it through the database, and then adjust the operation parameters as needed manually. So what happens if I come through here and say I adjusted the operation parameters more heavily? Not only did I save the tool, but I adjusted the feeds and speeds, I adjusted the depth of cut, the side allowance, I created some lead-ins and some lead-outs, and I spent a few minutes perfecting this toolpath. And also assume that this O-ring groove is a feature that I machine often. Enough so that I don't want to create or spend the time adjusting those parameters every day, or even more than once. What can I do? Well, as I said before, we can save these operation plans. To save it, we come back to the feature tree, and we're going to right-click on the feature. Now this is a subtle step in the process, but it's a very important conceptual concept. We're saving the operation plan, but we're coming back to the feature, which means we're saving everything associated with the feature. So, in this case, I only have one operation associated with the feature. But, like when I mentioned before, for a whole feature, it's very possible that you might have 3 or 4 operations associated with that hole. You might have a center drill, a ream feature, and then you might have a countersink at the very end. By coming through and manually adding those one time and then saving it as a custom strategy, next time you use that custom strategy, it's going to pull all of those operations in for you. Let's save this, and I'm going to say create new feature condition, and I'm going to give it a new name, and we'll just say O-ring groove 2 since I already have one. Well, we'll say quarter inch, so I know that for my quarter inch O-ring grooves I'm going to use this size. I'm going to say OK, and this is showing me what it's saving to the database. Great. So now, how do I take advantage of that? Or how do I prove to you that what I saved is actually true? Well, I'll come back here and I'll delete this feature. And I'll re-add it. Choose my face, choose my depth, and then for my strategy, there we go, O-ring groove 1/4 inch. Once I choose that, I'll hit finish and generate the operation plan. And look at that, it shows my 3/16 inch tool that I had before and the exact same tool path. Great. So what happens if that O-ring groove changes size? Let's go back to the SolidWorks model and let's alter the sketch that controls the size of that feature. One click shortcut here is if you're not sure what feature created that geometry, you can click the face of that geometry and it will highlight the feature that created it. So we'll come in and we'll edit the sketch. We'll say rather than 0.65 inches from the edge, we'll say this is 0.5 inches from the edge. So our O-ring groove just increased in size, right? Now when I bump over back to CAMWorks, it's going to give me a warning. It says the part's changed. What do you want me to do? Do you want me to do a full rebuild or a light rebuild? Well, I'll tell you right now, when this window comes up, you almost never want full. Even though it's highlighted here as the default, don't press it. Because what happens is, when you hit full, it will take the features that you've created and it will run them back through the database. Which means any edits that you've made to the operation parameters will get knocked out. And you'll get the default database parameters. What you want is light. Light will just reevaluate the features and check to see if they've changed shape and then apply the same operation parameters as you already had before. So I'll hit light and then we'll check the toolpath. And if we look here, there we go. Now before, our O-ring groove followed about this path where my cursor is. This time we bumped it out, but the toolpath updated. And we can verify it updated again by running a simulation here. And a comparison. And we should see some green down there in the channel. Great. It's green. There we go. So now let's see some automatic feature recognition. The automatic feature recognition for CAMWorks is unparalleled as far as the integrated SolidWorks CAM software. If you ask SolidWorks, they probably would agree. Otherwise, they wouldn't be licensing it for some of their own feature recognition technology. For the SolidWorks users out there that have used FeatureWorks, which is the add-in that allows you to bring in an imported body and build a feature tree off of it. If you've ever used that, you've used CAMWorks feature recognition. It's the exact same technology. That gives you a good idea of just how integrated CAMWorks is into SolidWorks and what type of overlap they have in their technology. So I'm going to run the automatic feature recognition, and it's going to pick up the rest of the 2.5 axis features in this part, which means it's going to pick up the holes, it's going to pick up the face feature, and it's going to pick up these pockets here on the sides. What it's not going to pick up is this geometry here, the 3 axis. We're going to be left to do that manually, which we'll see is not too big of a deal. Automatic feature recognition is this top left button, the extract machinable features. I'm going to click that, and CAMWorks is going to analyze the part. Here's another important concept. It's that it's looking directly at the faces of the part. It's not looking at the SolidWorks feature tree. So it's not taking into account, say, a cut extrude and knowing that it's a pocket, It's just looking at the faces of the features, which is good because it also means that CAMWorks will work just as well on imported bodies, should you have to work with those. So what did it find? Well, I didn't lie when it said it would find the face feature. It also found the holes. Found this irregular slot here, which is not something that I would machine separately, so I'm going to go ahead and delete that feature. And then also found the rectangular pocket again, which we've already programmed, so we can just wipe that out as well. And then also found the odd brown pockets here on the sides. And as I alluded to earlier, it created the setups for us. Great. For the holes, it chose a drill strategy, which is the default. But maybe I don't want to drill these. These are going to be pinholes, so maybe I will ream them. Alright, so now that we have features, and we have the strategies that we want for each feature, let's generate our operation plan and run these through the database. By clicking Generate Operation Plan up in the top toolbar, it's going to generate the operation plan for all of the features in the part, as opposed to right-clicking on a particular feature and generating here, which would only generate the operation plan for that one feature. Both ways are useful depending on what you want to do. If I've spent some time programming a part and I have a lot of features and I'm really only concerned about one of them, I would generally want to use the right click. But for now, when I'm just beginning a part, Generate Operation Plan at the top there is going to save me some button clicks. This menu here, or this warning here, is asking what do I want to do with the operations that already exist. Because remember, for the O-ring groove, we've already got a contour mill operation. I'm just going to update. If I chose regenerate, it would run it through the database again, which I don't want. Alright. So you can see here what it's created is a face mill operation, a center drill, and ream, just like I promised it would, and then a rough and contour for each of these pockets. We'll generate the toolpath. And we've got some toolpath on these parts now. And again, the tools that it chose, the depth, feeds and speeds, side parameters, bottom allowance, NC planes, lead-ins, lead-outs, all of those operation parameters, the nitty-gritty details that make up each of these operations are all pulled from the database at that point. So it's our job as a CAMWorks programmer to take what the database gives us, evaluate it visually, just to confirm that it's given what we want, and then adjust accordingly. A good example would be this odd-brown pocket here. To me it looks pretty good. But if I wanted to change it, say I wanted to pocket it in or pocket it out, I could certainly do that. Pocket out, hit preview, it adjusts. Great. If that's how I want to program it, it took me 2 seconds, literally, to change that. The purpose of this webinar really isn't to go through and program this part in detail, but just to give you an idea of the workflow of CAMWorks and where some of these options are. For the contour mill, probably bad programming practice to plunge in, come around, and do a direct retract right on the same point, because we're going to get some witness lines and whatnot on this wall. So if we wanted to add some lead-ins and some lead-outs, we can certainly do that. Give it a simple arc lead-in, lead-out. It's still coming in and exiting on the same point, so I'll give it some overlap here. And there we go. Great. So now if we were to simulate this part, and run the comparison, notice I haven't really changed much from what the database gave me, and I didn't change any tool size or depth of cut or anything like that. And we're looking pretty good. Lots of green, right? That's exactly what we want. So we still have some blue. The middle portion, by now you probably would assume that we'd have blue because we haven't made any cuts. But what about those mounting holes? So remember I chose a reamer for those holes. And most likely what's happening at this point is that I have to admit, I created this model. I didn't create those holes. The size of those holes don't correspond to a standard reamer size. So if the programmer saw this, they'd probably come back to the designer and say, hey, do you really want these holes this size? And if they did, then we probably wouldn't ream them. We could bore them, or most likely what would happen is the designer would say, cut them to whatever size you need for that pin size. So it makes sense to me that those are blue, because CAMWorks isn't going to create an arbitrary tool to match the diameter of the hole. Great. So that's the 2.5 axis portion of this part. This is a mixed part, meaning it has 2.5 axis features and 3 axis features. So let's do the 3 axis feature. 3 axis features are treated differently than 2.5 axis in that we don't have to specify whether or not it's a pocket or a slot or a hole. The only thing we have to do is tell CAMWorks what surfaces do we want machined. So I'm going to come back to this setup here, which is again the direction that I'm going to be machining this feature from. And I'm going to add a multi-surface feature. I can come in here and I can start selecting features or surfaces to cut, but that will take too long, and I'll inevitably miss some features that are small faces. So what I'm going to do is I'm going to use this button here, select all faces, and I'm going to create every face in this model as part of my feature. And then I'm going to use a contain sketch to narrow down the scope of this feature in the next step. To me, that's just easier and a little bit less headache than trying to pick all of those faces. So this strategy drop down is going to be the equivalent to the window we saw before that had the rough mill, coarse, fine, corner round, O-ring groove, quarter inch, all of our strategies listed. These are going to dictate what operations are carried out on this feature. You can see this list is a bit longer for the 3-axis stuff. 3-axis has less features. You know, everything's the same type of feature, multi-surface feature, but it has more operation types. So 2.5 axis feature, we have basically rough mill, contour mill, and then all of your hole operations, drill, ream, center drill, face, what have you. For 3-axis, we have some very specific finishing and roughing operations that make our life as the programmer much easier. For now, I'm going to use a rough pocket and finish 3D step over. So now that the strategy is chosen, I can hit the green check and accept. And then I'll run my operation plan, run it through the database. And now, before I generate the toolpath, I'm going to add a contain area. Because remember, it still thinks the feature is the entire part. So if I were to generate the toolpath now, it would rough and finish everything on this part that it can get from this direction. It wouldn't try to do this bottom face because it can't hit it from this direction. But it would get inside these holes and whatnot, and that's not what I want. So in my SolidWorks model, I have this sketch called contain. And it's essentially tied to the top edges of this face, outlines it. So I'm going to tell CAMWorks, for these toolpaths, contain your toolpath to that sketch called contain. It's just a right-click insert contain area and finish. And we can see they're listed here now if we expand out the menus on the operations. So now I'll control-click both of these operations and generate the toolpath together. And this is going to chug away for a few seconds here. Let's see what we got. So we've got an area clearance operation with a 3/4 inch flat end mill and a 3D constant step over with a 1/4 inch ball nose. Probably for both of these operations, it's too big of a tool for what I want. So real quick, I'll come in and I'll use a smaller tool. Say I'm going to rough it out with a 1/4 inch. Change my tool, hit preview. A little bit better, right? And since I'm using a smaller tool, I should probably adjust my depth of cut so it's a little bit shallower. And I don't like how it's spiraling in, so I'm just going to ramp it in. Hit preview there. So with a shallower depth of cut, you can see now that we've got several passes, 1, 2, 3, 4, and no spirals. Great, exactly what I wanted. For the constant step over, again, I'll come in with a smaller tool. Should we go really small? No, that's a flat end mill. I don't see a ball nose in here that's small enough that what I want, so we'll add a tool from the library to our tool crib. I can hit add and I can filter by ball nose, and I'll choose a 1/16 inch ball nose. So adding a tool that's not in your tool crib is just a couple second operation there. And that's looking pretty good for the purposes here. Great. We'll accept that. And we're going to simulate this. So for the purposes of the simulation, I'm going to knock down the quality a bit for the simulation, just so it'll go a little bit quicker. And we'll simulate this here. Looks like I was cutting some air there, so I'd probably want to go back and adjust my Z limits. Right now my Z limit was most likely set to the top of the stock. And remember, we came back and we faced off the top. So for the distance there between the top of the original top of the stock and the top of the part that was faced off, it was just cutting some air. So that's one of those things that the more experienced users have most likely encountered, and hopefully you found the solution. If you haven't, I'll show you. If we come back here into the area clearance, I mean, we can see right away that it's making some cuts above the part, right? If we adjust the operation parameters and say in the first cut, instead of top of stock, say top of feature, and hit preview, it's going to recalculate those tool paths, and they drop down now. So now we have no tool paths above our part. And there we go. Every time I exit there, it keeps asking, do I want to regenerate? Since I hit preview and it regenerated, I don't have to regenerate it a second time. Alright, great. That's about it for this part. I think we're ready to post it out. Oh, I take that back. There's a couple more things that we should probably do. One is set our part 0, right? So that's one thing that the more experienced CAMWorks users might express some opinions on, is the ability to program your entire part and post it out with ever setting your part 0. It's really good practice and a really good habit to form to set your part 0 immediately. We do that by going into our part setup, and we can say, top of center. I hit OK, and we're going to have to regenerate the toolpaths. I'm sure the machinists out there have been watching, just waiting for me to do that, and when I said I'm ready to post out, probably screaming at their monitors because you guys are so passionate about CAMWorks, right? And then the last thing I probably want to do is reorder some of these operations because they're in a pretty inefficient order. So again, I can right click on the setup and say sort operations, and I can sort by the type of operation. So if I want my rough and my contour mill up top, and also my area clearance and my constant step over up there, hit apply, you can see these reordered instantly. So all the holes are treated at the end. We'll hit OK. This list here is fully customizable. So again, the more experienced users out there who have been dragging and dropping these every time, I'll show you my email at the end of the webinar, and go ahead and shoot me an email and I'll show you how to customize this menu or the order of this in the TechDB. Alright, so now I'm going to post-process. In this top toolbar we've gone left to right, and the next button that we have here is post-process. So for those of you unfamiliar with the post-processing concept, essentially everything we do in our CAM program, as far as where we're telling the tool to be, how it's going to get there, and what it's going to do when it gets there, is machine independent. It's written in CAMWorks language. Well, when it comes time to send this to your machine needs to be able to read it. It needs to be in your machine's language. So the post processor acts as like a translator. It translates the program data from CAMWorks language to your specific machine language. So it's really important to have a post processor for every type of machine that you have, because a Morisiki mill is going to require a different language than a Haas mill. And because whatever we do in CAMWorks is machine independent, means that we only have to program the part once, and then depending on the day we can post process it to whatever machine we need, simply by changing the post processor in that mill machine parameter. So that posted out, and we're left with this text file here that's our part program. Pretty cool, right? So we save this and we send it to the machine. We could save it to the network. We could throw it on a USB stick. We could drip feed it through DNC. However you guys want to get to your machine is fine by me. So I'll save this part. And again, I mentioned this before, when we save it, all of this CAM data is stored within the SolidWorks part file. So, say we as the programmer finish this part file, and the designer opens up the SolidWorks file tomorrow, makes some adjustments, and tells the programmer, hey, I made some changes. We don't have to start all over. We just have to open up the part, open up CAMWorks, allow it to notice that the part's changed, and update the toolpath for us. Pretty neat. So now, I promise you guys a little bit more complex programming environment. So I have this tombstone set up with our Kurt vices that are holding our mold part all around. So what we're going to do here, imagine this is set up on a horizontal mill. We're going to take the data that we already programmed for this part, import it into this assembly, and we can tell CAMWorks that, hey, since you're in this assembly and we want to cut these parts, treat these vices in this tombstone as a fixture and avoid them. Which means if we had any toolpaths that would intersect with these, it would adjust the toolpaths. Now, in this case, we don't have any toolpath that actually would intersect, so I'm basically showing you this just to show you that it's there. You might just have to trust me, or if you don't trust me, set something up like this with, say, a part perimeter toolpath and try it out for yourself. It works. So in assembly mode, we have to tell it what parts we want to machine. So I'm going to add this part, all instances of that part. And then before I do anything else, I'm going to tell my CAMWorks that we have 4-axis capability for this machine. So I'm going to go to my setup, and I'm going to say you can do 4-axis, and I'm going to choose this coordinate system, which is a SolidWorks coordinate system that matches to the coordinate system that would be on my machine. And then I'm going to say the rotary axis is the y-axis, and then you can move in both directions. That's a key difference between part and assembly mode, is that in assembly mode we absolutely need a SolidWorks coordinate system, and we need to set it up in our machine. Okay, so now that I have the machine set up and CAMWorks knows what parts it needs to machine, I'm going to tell it to import the part data from the part file. There we go. These should look familiar, right? It's exactly what we did before. So now I'll generate my operation plan. And generate my toolpath. And nothing's really new here. It's pulling in exactly what we did before, which is saving us a lot of time, right? Because imagine you're given a small part and you program it, and then tomorrow you said, okay, well now we need to create a setup for this, and there's going to be 100 of them on a pallet. Well, that could be pretty daunting, right? Well, CAMWorks makes it easy, because we're programming 4 parts here all at once. CAMWorks is going to take into account the distance between all of the parts. It's going to take into account the setup, so it knows what direction it can machine from. And it's also going to take into account the fixtures or the vices. So if you have clamps, if you're using bolts to hold the parts down, if you're in this case using vices, again, CAMWorks can be made aware of those and told to avoid those with no problem. Alright, so those are just about done generating. Last thing I'm going to do is I'm going to sort the operations. And this time I'm going to sort them by and across setups. So that means, as it is right now, it would machine out one part, rotate, machine out the next part in its entirety. Not the most efficient, right? Because we're going to have 4 times the number of tool changes that we need. But by sorting by and across setups, we can tell it to choose one tool, say the face mill, hit all 4 parts, then move on to the next operation. So I'll move these in the order that I want and hit apply. You saw this all updated. And then the very last thing I'm going to do is add these fixtures. For now, I'm just going to tell it the tombstone. Alright. And when we simulate, if I had added the vices, it would have displayed the vices as well. And run these. There we go. Not bad, huh? Not much work. Really cool. This is one of the coolest things that I've seen CAMWorks be able to do. Because it's such a complex program, but by being able to break it up into the part file and then import the part data, makes it so much easier. And that about does it for us today. So, as I mentioned before, this webinar is being recorded. So you can come back and you can watch it as many times as you want. You can find it posted on our YouTube page, youtube.com/GoEngineer. You can also find it on GoEngineer.com. And you also find links to it on our Facebook and Twitter. If you have any questions for me about what I've shown you today, or if you have questions on the capabilities of CAMWorks, maybe you're not a user yet, or if you're an experienced user and you have some open issues, or if you have some parts that you want some suggestions on, or some advice, or whatever type of questions you have, go ahead and contact me. treed@goengineer.com. I'm looking forward to hearing from you guys, and be sure to tune in next time. Thanks.